Ian is the director of HyEnergy Consultancy. He runs the energy consultancy business based in the UK and acts as a business development director for companies finding their initial business in Europe and the UK. HyEnergy brings sector expertise to bear in various EU-funded projects such as Seafuel and GenCom, and prepares proposals for consortia such as the first ever Hydrogen Valley project funded by the FCHJU, the Heaven project that Nigel referred to. The company extended its operations to the Netherlands last year. Ian has over 30 years' experience in industrial gases, primarily in the hydrogen energy sector, having worked for Air Products. He's also been the CEO of one of the few British fuel cell companies, AFC Energy, so he has wide-ranging energy supply and application expertise. Finally, Ian has been president of the European Hydrogen Association for the last 10 years. Ian also works with us, as I said in the warm-up there, in GenCom. He's one of the leading the technical work package in GenCom. But today, Ian's coming in from the European Hydrogen Association, given that link. Something we referred to at the start, it's a joint journey. The highway to net zero at the minute is a one-lane road with different technologies and partners. We need to widen that into a 4-lane or an 8-lane highway. And that's one of the goals of all the different hydrogen associations, be it the Scottish Fuel Cell Association, our own Hydrogen Ireland, and the European Hydrogen Association. How do we get everybody onto that highway? Ian, over to yourself. Thank you very much indeed.
Thanks, Paul. I'm going to have to get you a different picture, I think, for in future. I think that must be the last time I wore a tie in these things. Anyway, good morning, everyone. I'm just, as Nigel mentioned, I'm going to talk a little bit about tidal and marine hydrogen production, and I want to centre it around some of the activities that are going on up in the Orkney cluster. Nigel was kind enough not to touch on this particular project, so we want to try and give you a little bit more of a flavour as to how that could look in the future and what it means across the board, shall we say. So a little bit about HyEnergy. Paul's done a great introduction for myself, but HyEnergy looks to connect renewable companies or renewable energies with hydrogen. And we've been participating in a number of different projects. And as Paul mentioned, GenCom and Seafuel are some of those projects. But we also write projects, and we wrote the ones that Nigel has referred to, the Green Highland project and the Heaven project, where we integrate large numbers of companies to look for a common vision in a particular region. And then finally, the Enable H2 project is an aviation project, which we're working with various members in around Europe, looking at how we can put liquid hydrogen onto bigger jet airliners, which will come in post the work that's being done by Nigel on Orkney. In terms of the other activities that we look at, when we write these projects, we also participate in them. We work with many different stakeholders in the field in terms of producing reports and studies. And we do a little bit of market representation where we look after companies' interests in certain markets. And that's led us into this project called ITEG, where we look after the interests of one of the electrolyzer companies in Europe, a company called Elogen. So we've heard a little bit from Nigel about what Europe is looking at in terms of its future progression towards net zero. And, you know, we've done quite well in terms of the historical picture. You know, we set ourselves a target of 20% by 2020, and everybody achieved that. In fact, we got a better result than we expected. The problem is that in order to get to 2050, we need to accelerate. In order to get that that acceleration, we need to identify new routes for renewables, new locations for renewables, and we need to integrate them with hydrogen as quickly as possible. The goal now has shifted. By 2030, it used to be up at about 36%. Now we need it to be 55%. And in the UK, as Nigel mentioned, we're looking at about a 75, 78% number by 2035. So every country is beginning to tighten its environmental process and its environmental requirements, and that is driving industry forward at an accelerated rate. So what does that mean in terms of renewables? Well, the EU has targeted 40 gigawatts of offshore renewables, or sorry, general renewables by 2030, with that growing to maybe 300 gigawatts by 2050. Now, they seem like enormous numbers, and in fact, they are enormous numbers in terms of what we have in place today. But if we look at the actual space, and remember that when we looked at land-based renewables, most of the issues that we get in terms of placing turbines is all about the fact that they inhabit areas where people like to go and enjoy themselves, like to enjoy the scenery and enjoy the outdoor space. So if we look at that in terms of a marine space, obviously we still have an impact on the environment there, but even to get to this 2050 goal, we're only going to be looking at a very small percentage of the total marine area. And that leads us to potentially have a lower impact on the overall environment if we follow an offshore principle. So at the moment, what we see is that the offshore and solar opportunities only account for a very small percentage of global energy requirements. And what we need to do is to step that up. And we see that potential occurring, as Nigel's map indicated. This is all about clustering and electrification of energy streams in the future. So today what we have is a very good success in terms of creating renewable electricity, and we need that electricity to begin to penetrate into other energy value chains, such as natural gas, such as fossil fuel mobility. And we're seeing those changes begin to occur today. And even if we look at the success that we've had in the last 5-6 years, we've seen green hydrogen pricing drop dramatically. But what we already know, and again, referring to the map, and I do like that map, Nigel, I'll have to steal it from you at some point, the map which shows the areas of Europe that will require importation of energy, that, in other words, hydrogen that they cannot actually manufacture themselves. So we know that certain parts of Europe will require the movement of energy in the future. And we're already seeing that the renewable energy picture is beginning to encompass that. So we're seeing plants being built in the Middle East and in Australia, looking for their customers in different countries and creating mechanisms to move those molecules or those electrons across the world in different forms. And the forms that are being looked at the moment are mainly chemical. So we're looking at ammonia or methanol. Or it could be that they get dissolved into or adhered to a liquid organic hydrogen carrier. And that will allow us to operate those transfer mechanisms with the most efficiency. But when they get to the shores or the locations in Europe which have these higher demands, we're then going to actually have vast amounts of energy coming into our port networks. And then we're going to need to migrate that energy across the rest of Europe. We'll use natural gas pipelines for that. We convert it into hydrogen, but we're also going to see our chemicals infrastructure converted to renewable structures as well, and thereby undergo this similar electrification. So this is all about scaling up this demand. And if we look at some of the predominant renewables, obviously wind is one of those. And in Europe, what we've seen, and again, referring back to Nigel's slide, he looked at the UK's position on wind. If I take you a little bit further towards the European coast and look at Belgium and the Dutch coast, we see the scale of electrolysis and the scale of wind investments becoming increasingly large, and with plans to go still larger over the next decade. And we're seeing the development and both business development and first stage equipment development of multiple numbers of electrolyzers. These electrolyzers are in the hundreds of megawatt scale. Just, let's say, 2-3 years ago, we were looking at 1 megawatts being a world scale PEM size electrolyzer. So what we're seeing is that this technology is scaling very rapidly, and those graphs in the middle of this particular slide show how quickly we're seeing that picture change. We're seeing the average size of each electrolyzer installation that's actually gone in the ground grow, and we're seeing the future potential in terms of the planned electrolysis systems also grow markedly. And it's a bit like this hockey stick approach. And then on the far right, you can see a couple of the Belgian projects that are beginning to manifest themselves: the High Ports project at Ostend and the Aquaventus project, both looking at significant amounts of wind going into hydrogen in terms of the gigawatt scale project. But it's not all wind, and we shouldn't just assume that offshore means, offshore wind. We have the opportunity of looking at 3 other different marine technologies, one being floating solar, another being wave, and one that I will focus on for the rest of this presentation, which is tidal. So tidal has this position in that it's always been nearly there, nearly getting to the stage where we get a commercial project. We've had a number of false dawns, a bit like the hydrogen false dawns of a few decades ago. But what we're seeing now is some new companies entering into the fray, if you like, and scaling up some of the technologies that have hitherto been deployed by other companies that have since failed, if you like. So we're seeing that this position in terms of tidal still needs support because the investor community is not completely aligned to its future potential yet. But we are also seeing that those innovative companies, normally based either in the UK or along the European coastlines, are coming forward with new technologies and creating new designs for us. And the IEA has already positioned its stall, if you like, that it expects tidal to play a part in this renewables future that we're all going to see. And in order to get to where the IEA believes that marine energy, or at least tidal energy, should be, we need to see something like a 20 to 30% year-on-year growth rate in order to achieve that position. So not only are we going to see the offshore wind position accelerate dramatically, but we're also going to see tidal copy that acceleration, albeit at a much lower level. So the reason why the UK is particularly interested in tidal is it's probably got some of the best tidal resource in the world, and that I would include Ireland in that as well. And we've seen some of the initial development projects go on around our shorelines as well. So this particular technology could offer the UK and the coastal regions of Europe a very prominent position that could be then used as an export market going forward. And I think that's what the European Union is particularly interested in. If I introduce you to the motley crew that are running the ITEG project, it's a group of companies and academic institutions that have come together in order to try and facilitate the proof of marine energy integration into the European electrical grid, but using hydrogen as a storage mechanism. And you've got 3 main technology actors. You've got Orbital Marine, you've got Elogen, and you've got EMEC in terms of the infrastructure positioning. And what I'd like to do over the next few slides is just give you an indication as to how all of that begins to fit together. So we have Orbital Marine as part of this consortium. They have recently just built this thing called the O2 tidal turbine. It's currently being positioned in Orkney, just off the shoreline of Edy, the island that Nigel mentioned. And that will then be moored there, and it will be cabled up to Edy to allow its energy to be managed by a new energy management system. Apologies, the T moved there by the looks of it. That energy management system is going to be designed by EMEC, and then that will feed either energy into the grid as required, and where it can't be fed into the grid, it will be fed to an Elogen electrolyzer. And this electrolyzer is quite special because it's capable of running at different rates. In other words, it has a nameplate capacity of 500 kilowatts, but it's also capable of running at higher loads for short periods of time without impacting its longevity, its lifetime. And that can potentially offset the need for the batteries that Nigel was mentioning in terms of the overall scheme. So what I want to do is introduce you to these components in a little bit more detail. And really the key one is the tidal turbine. It's Orbital Marine has been working on this turbine for the last 2 or 3 years. You know, just to give you some element of scale, this thing is 72, 73 meters long. The rotors are 20 meters in diameter. They have a, if you like, a 600 square meter area when they rotate. It's an enormous beast at the end of the day. And like this slide says, it does look pretty cool, and it probably belongs, you know, more in a Star Wars movie than it does in Orkney at this particular moment in time. Mind you, given that Star Wars is filming in the UK at the moment, maybe they can get up and film this as well. But the key piece are the rotors. The key pieces are how those rotors go into the water and how they can then be moved in a form of a gull wing type structure to allow them to be maintained in a very easy, an easy way. So this, as I mentioned, this was launched only about a month ago. It's been since towed and maneuvered into place on Orkney, and is effectively beginning its commissioning process. Now that's going to be coupled with an electrolyzer, as I mentioned. We're going to be putting, it's a standard containerized electrolyzer system that will be placed on Edy. The beauty of this particular location is that it is effectively in a marine environment. I mean, we are maybe 20 or 30 meters from the beach on Edy for this location. And we see that in future, there's going to be many applications where electrolyzers will need to be deployed in marine environments. And we haven't really had significant understanding or significant operating experience as to how these electrolyzers will work in this type of environment in the past. So this is one of the key learning experiences that we expect to get from the ITEC project. We expect this electrolyzer to be able to load follow and also to be able to manage its production in such a way that it stays warm, so it's very reactive, but that it also is able to, as I mentioned, peak load itself so that it can maximize its output potential. And then what do we think that this begins to look like in the future? So we know that we're going to have many offshore wind farms, and we also know that we can begin to site floating solar in certain calmer areas of the sea. So if we add in this interface of tidal turbines as well, we begin to get a maximum use out of the marine environment within the areas of the sea that we want to actually exploit. And so bringing the energy together from all of these different renewable options, it makes sense. So if we look at what's beginning to happen on the continent, we see the Dutch and the Danish begin to contemplate the positions of developing new offshore energy islands. And on these islands, we will see the interconnection of all the existing renewables, and the placement on the islands of the electrolyzer systems to convert this this energy, or at least some of this energy, to hydrogen, and then use potentially existing oil and gas pipelines that flow across the North Sea in a very regular way at this particular moment. So reuse that existing infrastructure to allow the hydrogen to then be transferred ashore in the most cost-effective way. And just to give you some concepts, putting in a wire versus putting in a pipe, the cost here is it becomes significantly more beneficial to put in a pipe in terms of energy transfer mechanisms. So gaining that additional cost benefit is also important to green hydrogen as it tries to compete with existing fossil-based fuels that it needs to displace in the future. So this is a very positive way of creating that long-term value chain. So in summary, the UK is an island nation, but also obviously the EU has a significant coastline. We expect that the tidal opportunity to be exploited by these coastal nations, because the expertise in terms of the company developments lies in the majority part along the coast. And we're beginning to see the first instance of that within the ISEG project. And being able to manage this interface between putting the incoming renewable energy either to an electrical grid or to a hydrogen process is a key part of what EMEC are bringing to this particular picture, because that energy management system could then be deployed on a scaled up, wider basis. So thanks very much. That's what ED looks like, and you can see the beach there very close to where we're trying to work. That's why we're quite confident that the marine environment that we are experiencing there will be the same as if we put it on one of these islands in the middle, energy islands in the middle of the sea. So I'll end it there, Paul. If there's any questions, look forward to it.
Ian, gentlemen, many thanks.